Hello grade 8 and welcome to session 4 of our lesson, which is the circle. This is teacher Sarah. So, what is a perpendicular bisector? A perpendicular bisector, its properties, it divides AB into two equal halves, passing through the midpoint of the segment. It makes a right angle, or in other words, it is perpendicular to the segment. The third property, every point on the perpendicular bisector is equidistant from A and B. So as you can see here, XY or MN is the perpendicular bisector of AB. Why is it a perpendicular bisector? It passes through the midpoint I and it is perpendicular to the segment AB. Alright, so we say that XY is the perpendicular bisector of AB. Any point belongs to the perpendicular bisector is at equal distance from the endpoints or extremities of the segment. So MA equal to MB and NA is equal to NB. Before we start, let's review and talk about the perpendicular bisector. First of all, we're going to use the word equidistant when we say a point is equidistant from two objects if it is at the same distance from these objects. So equidistant means at the same distance. Let's see these two examples. As you can see here, D is the midpoint of A, B. So D is in the middle. We can say also D is equidistant from A and B. Similarly here, AC is equal to BC. So we can say that C equidistant from A and B. In other words, we can say that the point C is at equal distance from point A and B. So applying the perpendicular bisector theorem, it says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Let's take an example. Here I have segment AB. Alright? M is the midpoint of AB. Okay, I draw PM, a line perpendicular to AB. So in this case, if PM is perpendicular to AB and passing through the midpoint of AB, so PM is the perpendicular bisector of AB. So P, which is this point belongs to the perpendicular bisector, so AP is equal to PB. P is equidistant from the endpoints of this segment, so AP is equal to BP. Any point belong to the perpendicular bisector is equidistant to the endpoints of the segment. How to prove a line is a perpendicular bisector to a given segment? We have two options. One, either we say it is perpendicular and passes through the midpoint of this segment, or two, which we use it regularly, proving two points are equidistant from both the endpoints of the segment. These points belong to the perpendicular bisector of this segment. Let's talk more about number 2. Look at the given figure. Here, prove that XY or MN is the perpendicular bisector of AB. Okay, so I want to prove MN. Why is it the perpendicular bisector of AB, segment AB. We said that it's a property. 1. Any point belongs to the perpendicular bisector. It is equidistant from the endpoints of the segment. So, it is enough to prove that MA is equal to MB and NA is equal to NB. Look at the figure. Is this point the perpendicular bisector? I want to prove it a perpendicular bisector. Is MA equal to MB? Yes, given. Then M is equidistant from A and B. Is NB equal to NA? Yes, it's given. So N belongs to the perpendicular bisector of AB. It is equidistant from A and B. So MN, or we can say XY, the same. MN is the perpendicular bisector of AB. Whenever they say prove that MN is the perpendicular bisector of a segment, we take the first letter. This is the first letter. This is a point. And we prove MA equal to MB and NA equal to MB. Then we can say that this is the perpendicular bisector of AB. Let's solve this exercise together. Consider two circles, circle C of center O and radius 4 cm and C prime of center O prime and radius 5 cm, and OO prime, this is the line of centers, equal to 8 cm. The first question, what is the relative position of the two circles? Okay, before we draw, what is the relative position? As we said before, we have to follow these steps. First of all, OO prime is 8 cm. Second step, put R and R prime. Here it's 4, here it's 5. Third step, calculate R plus R prime and R minus R prime. Here it's 9 and here it's 1. The fourth step, we compare. Is 8 equal to 9? No. Is it equal to 1? No. 8 is in between 1 and 9. Alright, so whenever OO prime is in between R minus R prime and R plus R prime, so these two circles are intersecting circles, or we can say secant circles. Question 2, draw the two circles C and C prime. So, on your copybook, first of all, we draw the line of centers OO prime. Alright, OO prime, which is equal to 8 centimeters. Then you use your compass and put it at O and draw circle C of center O and radius 4 centimeters. This is circle C, 1. Then you put your compass at O prime, open it 5 units and draw circle C prime. As you can see here, the two circles are intersecting. Question 3. What are the axes of symmetry of the two circles? As we said before, the axis of symmetry, this is an imaginary line. It's always the line of centers. Okay? So, the axis of symmetry of this figure is the line of centers, which is OO prime. Question 4. Let A and B be the points of intersection of two circles, of these two circles, A and B. A and B. Please prove that these two triangles OA, O prime, OA, O prime, this triangle, and O prime and OB, O prime, OB, O prime, are equal. To prove two triangles are equal, by side 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 or side or angle side angle. As you can see here, OA is equal to OB, radii of the same circle. O prime A is equal to O prime B, also radii of the same circle. And we already have O prime is a common side. Then these two triangles are equal by side, side, side. Finally, I want to show that OO prime is the perpendicular bisector of AB. So let's write, as we said, I want to prove OO prime the perpendicular bisector of AB. Please use this way, it's the easier way. In other words, it means I have to prove OA equal to OB, and I want to prove O prime A equal to O prime B. Okay, let's look at the figure. So let's check from the figure. Is OA equal to OB? OA equal to OB? Yes, it's true, because the radii of the same circle. Is O prime A equal to O prime B? Yes, because the radii of the same circle are equal. So we can say that O is equidistant from A and B. O prime is equidistant from A and B. So, as a result, we can say that OO prime is the perpendicular bisector of AB. Okay, OO prime, it's the perpendicular bisector of the segment AB. By this, we finished our session. Thank you for watching. Goodbye.